In this class, let us study about polygons. Polygon is a figure which is simple, closed and made up of line segments. Now what do we mean by the term simple? Any figure is said to be simple if its sides do not intersect or cross themselves. That is, something like this does not happen. The sides should not intersect or cross each other. Now what do we mean by closed? Any figure is said to be closed if it does not have any open endpoints. See the two endpoints here? In this case, this figure is not closed, it is open. And how do we make it closed? There. So this way it does not have any endpoints. You start at one point and then you can come back to that point. Such a figure is said to be closed. Now let us see some examples and counter examples from polygons. We will see some figures which you already know. What about this? You know what it is called. It is a circle. This is an example of a figure which is simple. There is nowhere where the sides are crossing themselves. It's closed. There are no open endpoints, but still it is not a polygon. Why is that? Because it is not made up of line segments. So this is not a polygon. It is a simple closed figure. Now again, a figure which you already know, a star. This again is not a polygon. Why is that? It is made up of line segments. It is closed, but it is not simple. Why? Because see how many places the sides are intersecting themselves. Here, here, the sides keep on intersecting. So this again is not a polygon. What about the English alphabet Z? It is made up of line segments. It is simple, but it is not closed. See the end points here? It is open. If you do like this, it will be closed. So Z is again not a polygon because it is not closed. Now what about this? This is a polygon. Why? It's made up of line segments, it is closed and it is simple. Now can you tell me the least number of lines required to make a polygon? Can you make a polygon with just, if n is the number of sides, if n is the number of sides of a polygon, can you make a polygon with just one side? The answer is no. Why? Because it is not closed. You see the two end points, it is not closed. Can you make an polygon with two sides? Again, no. What about three sides? So, the minimum number of lines required to make a polygon is 3. And what is the name of a three-sided polygon? You know what it is called. It is called a triangle. And what is the name of a four-sided polygon? It is called a quadrilateral. Now, these names are derived from the Greek numbers. Anything tri is 3. Anything quadra would be 4. Now we will see the names of the polygons with up to 10 sides. Now these are the names of the polygons having up to 10 sides. Now all these names are derived from Greek numbers. Anything tri deals with 3. Now you will notice a very interesting thing here. See this. So anything septa would be 7. But then why is September the 9th month in our calendar? Similarly, see octa. Anything octa would be 8. That is why we call the octopus an octopus, because it has 8 tentacles. But why is October not the 8th month? It is the 10th month. And similarly, deca. In English, decade is the word used to denote 10 years. So December should be 10th, but it is 12th. Can you guess why? There is an interesting story behind it. In the beginning, the calendar only had 10 months. It started with March and ended with December, and it had only 304 days in a year. So later 2 more months were added. January and February were added. So what happened is that all the months slipped 2 places down. So what was 7th became 9th, and then what was 10th, it came down to 12th. All of them slipped 2 places. So that is the story about the calendar. And then in some books you will see septagon written as heptagon also. They both are the same. One is Greek and the other one is Latin. And also hexagon, you will see in some books, you will see it written as hexagon also. So it is a simple, it's a difference in the language, Greek and Latin, but it means the same thing. Now we will go on to some properties of polygons. Now I have randomly taken a polygon of 5 sides. What is it called? It is called a pentagon. Its name is written by taking its vertices in a cyclic order. So A, after that we come like this. Now this will tell you information about all of this. So we start with the vertices. What are the vertices? A, B, C, D, E. That are the 5 vertices of this pentagon. And next we go to sides. What are the sides? A, B, B, C, C, D, D, E and E, A. So these are the B, C, C, D, D, E and E, A are the sides. Now given any side, so randomly I will take D, C. Now given any side, it will tell you what are its adjacent sides. Adjacent means what come near, what are the nearby sides. So if you take BC, 2 sides are said to be adjacent if they share a vertex. So you take this side, it has 2 vertices, right? D and C. Whatever other side share D or C, those are said to be the adjacent sides. So what are that? ED and BC. So these are the adjacent sides. Now what are the opposite sides of BC? Any side which does not have the vertex D or C, or in other words EA and AB. These are the opposite sides. And for this you don't even need the picture. Just write down its name. You can get the answer from the name itself. DC. What are the 2 sides which come nearby? This side comes nearby and this side comes nearby. See, BC and ED. You have the answer there. Now if you have any vertex, for example here I will take D. If you have any vertex, what is a nearby vertex? A nearby vertex is a vertex which shares a side. So if you take D and see the lines which go through D, then the other end point of that would be the adjacent vertex. So CD, it shares this side. So E is the adjacent vertex and C, this one, it shares the side. So this is again an adjacent or a nearby vertex. And now what are the opposite vertices? Opposite vertices are the vertices which do not share a side. That would be A and B. Now we come to the last one, which is the diagonal. Now a diagonal is a line which is drawn by joining 2 opposite sides. So the diagonal from say D, what will that be? You cannot join it to the adjacent sides, right? Adjacent sides, there is already a side joining them. You can only join it to the opposite sides. So you get 2 diagonals from D. That would be DA and DB. Again, you don't need the picture for it. You just need to know its name. See? Now, what are the sides from D? It will be CD and DE. These are the ones which come nearby. What are the diagonals from D? What does not come near it? DA and DB. These are the diagonals. So just from its name, you can know all of these things. Now let's go on to some properties of polygons. Now let us see some properties of polygons. Suppose there is a polygon of n sides. Then the sum of interior angles of that polygon is given by 2n minus 4 into 90. Now for example, I will take a polygon of 5 sides. What is it called? It is called a pentagon. A pentagon is a polygon of 5 sides, right? So now what this formula says is that we have the sum of the interior angles. What is the interior of a polygon? This will be the interior of a polygon. And how many angles will we get? We will get 5 angles. There we have got 5 angles. what this formula says is that all of these angles, 5 angles added together will be 2 into 5 minus 4 into 90 degrees, which will be 10 minus 4, 6. It will be 540 degrees. Now notice that you do not know what the individual angle measures are. All you know is that all of them added together will be 540. Now what is the next formula say? The next formula gives you the sum of the exterior angles. Now what are the exterior angles of any polygon? The exterior angles are what you get when you extend the sides. So there you have a side, extend it like this, you get an angle here. See the second side, extend it like this, you get the second angle. This is the first angle, this is the second angle. And now extend this, here you get the third angle, and extend this side, you get the fourth angle, and extend this side, you get the fifth angle. So there a pentagon which has 5 sides has 5 interior angles and 5 exterior angles. Now what are the sum of these 5 exterior angles? It will be 360 degrees. Now did you notice one thing here? The sum of the interior angles depends on the number of sides. See, in the formula you have an n here. So the interior angles, their sum always depends on the number of sides. But look at the sum of the exterior angles. Irrespective of whether it is a triangle, it's a quadrilateral, it's an octagon, the sum of the exterior angles will always be 360 degrees. And notice, this just gives you the sum of the angles. It does not give you the individual angle. Now this brings us to something called a regular polygon. Now what is a regular polygon? A polygon whose sides are all equal. So if suppose it has n sides, so all the sides are equal. So if all the sides are equal, that all the angles are equal. So you see what's happening here? If it has n equal sides, means it has n equal angles. So if 2n minus 4 into 90 is divided equally into n, so what will be each angle? Each angle will be 2n minus 4 into 90 divided by n. So if you have a regular polygon, in an ordinary polygon you don't know what the individual measures are. All you can see is that added it gives 2n minus 4 into 90. But if it is regular, it means all of these angles are equal. So you can know the individual angle. In the case of exterior angles, what will happen? If the sum of n angles is 360, so each exterior angle will be 360 by n. So now what does this tell about this? Suppose this is a regular polygon. This is not. This is just a pentagon. Suppose it is a regular pentagon. So regular pentagon means what? Its sum of its interior angles. We learnt that it is 540, right? But what if it is regular? Then each angle will be 540 divided by 5. So each interior angle will be 108 degrees. What about each exterior angle? Each exterior angles will be 360 degrees by 5, which means each exterior angle will be 72. So if a polygon is regular, you can know what each angle is. If it is not regular, all you can know is the sum. Now I will show you 2 more examples of this. Suppose, consider n is equal to 3. Now you already know, if n is equal to 3, what is the name of the polygon? It is called a triangle, right? And then if it is a regular triangle, if it is a regular polygon of 3 sides, what will that be called? What is a triangle whose all 3 sides are equal? It is called a equilateral triangle, right? So if you have an ordinary triangle, the sum of the interior angles will be 2 into 3 minus 4 into 90, which will be 6 minus 4, 2 into, So it will be 180 degrees. All you will know, if it is an ordinary triangle, all you will know is that all the angles added together will be 180. But then if it is an equilateral triangle, you will know that each angle is 180 degrees by 3, which is 60 degrees. So in an equilateral triangle, each interior angle will be 60. This will be each interior angle, okay? And each exterior angle will be what? Will be 360 degrees by 3, which is 120 degrees. So for an equilateral triangle, you can know that each interior angle is 60, each exterior angle is 120. Now, what about if n is equal to 4? Then what do we call it? For any n is equal to 4, the polygon is called what? It is called a quadrilateral. Now, what do we call a quadrilateral whose all sides are equal? You will remember that it is called a square. A square is a four-sided figure whose all four sides are equal. Then what will be the sum? The sum of all the angles will be, it is four sides, right? So 2 into 4 minus 4 into 90 degrees, which is 360 degrees. And what is each angle? All the four angles added together will be 360. Each interior angle would be 360 by 4, which is 90 degrees. So 90 degrees is the angle of each square, the interior angle of each square. And what will be each exterior angle? That again would be 90 degrees. So these are the two important formulas. Then now we will study one more formula which will tell us the number of diagonals of a polygon. Suppose there is a polygon of side n. So whatever that n is. So if it has side n sides. So now we will see that the number of diagonals is n into n minus 3 by 2. Now looking at this, can you tell me what will be the number of diagonals when n is equal to 3? Now what do we call a polygon which has 3 sides? It is called a triangle, right? So according to this, the number of diagonals a triangle has is 3 into 3 minus 3 divided by 2, which is 0. Now does that make sense? Look at a triangle. Look at this. So what is a diagonal? Diagonal is a line which joins two opposite sides. Look at A. Does it have any opposite side? The two other sides, which are B and C, are as adjacent sides because they share a side. So actually no vertex in a triangle has an opposite side, which means there are no diagonals at all. So therefore a triangle has no diagonals. What about a quadrilateral? Now what is a quadrilateral? Quadrilateral is a polygon with side 4 sides. So according to this, how many diagonals does it have? It has 4 into 4 minus 3 by 2, which is 2 diagonals. That makes sense, right? Look at a quadrilateral. This is one diagonal and this is another diagonal. Sorry. It should join two opposite sides. There. That's it. Now let us see a few examples and see how we can apply these two formula that we have just now learned. Now let's try to solve some questions. This is the first question. We are given two polygons. Now the second polygon has twice the number of sides as compared to the first polygon. So suppose the number of sides of the first polygon, if that is n, then the number of sides of the second polygon will be how much? It is twice. So if this is n, then the second polygon will have 2n sides. And what is the next thing given? It is a ratio of the interior angles. Notice that it is a regular polygon, which means you know what each angle is. If a polygon has side n, then its each interior angle will be you know that only if it is a regular angle, right? If a regular polygon. If it is an ordinary polygon, all you know is the sum. But this is a regular polygon, so you know that each angle is this. Now what about the second polygon? The same thing, but in the formula, wherever you have n, you put in 2n. So each interior angle of the second polygon will be 2 into 2n. Wherever you have n in the first formula, you put in 2n. What does the question tell us? The question tells us that the ratio of their interior angles is 3:4. So that means the whole by this one, 2 into 2n would be 4n. Now how do we divide fractions? We take the reciprocal of the fraction which is in the denominator. The numerator we keep as it is, right? So this is the numerator. We don't need to disturb it. We will just keep it as it is, but we will take the reciprocal of the denominator. That will be so there is a 90 and 90 gets cancelled, n and n gets cancelled. So you get 2 into 2n minus 4 by 4 is common, right? So I'll take 4 out. Again this cancel here 2. Then what do? We cross multiply. So this was 8n minus 16 is equal to 6n minus 6, which means 2n is equal to 10, which means n is equal to 5. What does that mean? The first regular polygon has 5 sides, which means it is a pentagon. And if this is the first polygon, what about the second one? The second one has 2 times more. If this is 5, the second one will be 2 into 5, which is 10 sides. And what is that called? It is called a decagon. That is the second polygon. Now let's go on to the second question. Let's go on to the second question. Again we have a regular polygon here, and this time what is the information given? The exterior angle is only 1/3 of the interior angle. So as usual we started with the number of sides. Okay, let the polygon have n sides. It's a regular polygon, so that means we know what each angle is. Each exterior angle will be 360 degrees by n. And each interior angle will be 2n minus 4 into 90 degrees divided by n. And what is the information you have? The exterior angle is 1/3 of this. That means if the interior angle is this, 1/3 of the interior angle gives us the exterior angle. Now, do not think you can cut the n here. See, this is a bracket, which means this is one whole term. You cannot just cut the n from this, so you cannot cut like this. 2n minus 4 by 90. This is 3 into n, right? 3 into n is equal to 360 by n. Now, I will just keep this term here, this one inside the brackets, and then I will cross multiply the rest. So this term which is in the denominator goes to the numerator, the one which is in the numerator goes to the denominator. So n and n gets cancelled, plus and this gets cancelled, this becomes 4. 4 into 3 is 12. So you have 2n minus 4 is 12. That means 2n is equal to 4 plus 12, which is 16. So that means n is equal to 8. So what you have here is a regular octagon. Now let's go on to the next question. Now we come to the third question. In the third question, we have a regular pentagon. Before we go to a regular pentagon, what is the sum of the interior angles of any pentagon, any ordinary pentagon? It will be 2 into 5 minus 4 into 90 degrees, which would be 540 degrees. This is for any pentagon. All you know is that all the 5 angles together will be 550. But then here, what kind of a polygon do you have? It is a regular polygon. So, not just the sum of the 5 angles. You know what each angle is. Each angle, if this 540 is divided equally into 5 angles, then each angle will be 108 degrees. So the minute you hear the word regular pentagon, you should know that each angle is 108 degrees. Now next, what do we have? There is a bisector of this angle, which means this angle A is being bisected by the line M, AM. So if the whole angle is 108, what does bisect mean? Divided into 2 equal parts. So if the whole angle is 108 and if this line divides it into 2 equal parts, so each part will be 108 divided by 2, which is 54. So each angle will be 54. Now what is the question? The question is, what is this angle? So can you think of a way we can find this angle? What if we consider this quadrilateral A, B, C, M? What if we consider that quadrilateral? We know one angle MAB. We know that to be 54 degrees, and we know that it is a regular pentagon. That means this is 108, this is 108, all these angles are 108. So there you have angle B is 108, and then you know angle C is 108. You just have to know the fourth angle of this. You just have to know what is the fourth. And how do we know that? It is a quadrilateral. That means its sum of the angles will be 360. That means MAB plus B plus C plus M, all of them together is 360 degrees. That means 54 degrees plus 108 degrees plus 108 degrees plus angle M is equal to 360 degrees. All of these 4 angles together will give you 360 degrees. So that means, all of this added gives 270 plus angle M is equal to 360. That means angle M is 360 degrees minus 270 degrees, which is 90 degrees, which is a right angle. Now let's go to the next question. So we come to our fourth question, and what do we have here? It is a quadrilateral. Unfortunately, it is not a regular polygon. We don't know what each individual measure is. All we know is that these 4 angles added together will give you 360 degrees. So let us just write down what we know. We don't know what the individual angles is, but we do know that all the 4 angles added together should give you 360 degrees. But then look at the question. The question talks about half of angle C plus angle D. So what if we half it throughout? That means we take the half of each term, and do not forget to take the half of this side also. So we have half of angle A plus angle, I will write half for each one separately. So we are going to take the half of each term. And do not forget, we take half of this also. So From here, where do we go? What does the question say? The question says that AO is a bisector, which means it cuts it into half. So this is one half and this is another half. And the same thing, OB is also a bisector, which means it cuts A into half. So you have angle OAB is actually half of angle A because it bisects, right? But and similarly OBA is also half of angle B. Why? Because it bisects angle B. But then these three angles added together, what is this? If you consider the triangle OAB, what is the sum of the angles of a triangle? You remember it is 180. So therefore half of angle A plus half of angle B plus this third angle. If you consider triangle OAB, half of angle A, half of angle B plus angle O should give you 180 degrees. That means half of angle A plus half of angle B should give you 180 degrees minus angle O. So, but then we can substitute it here, right? So, 180 degrees minus angle O plus half C plus half B is equal to 180 degrees. So, shall we take all of these terms? Just leave these two terms here and take the rest over there. We will just leave these two terms here. So it is plus here, already 180 is here. So when we take this 180 to this side, it becomes minus 180. And if we take minus angle O to this side, it becomes plus angle O. So 180 degrees minus 180 degrees is 0. So we have half of angle C plus angle D is equal to angle AOB. Let's go to the next question. With this we come to the end of this chapter. This is the last question. We have a regular pentagon. The minute you hear a regular pentagon, you should know that all the sides are 108 degrees, right? Now next, what do we have? We have the angle bisectors of two angles. One is A and one is C. The angle bisector of A meets CD in M. What does that mean? If the whole angle is 108 and M divides it into half, so each angle will be 54 degrees, right? And the second is the angle bisector of C. That meets EA in P. So that, what does that mean? Again, each one will be 54. So now our question here is, what is COM? This is the angle that we have to find. So how do we find it? It's a very easy thing, right? We have to consider this triangle. You see the small triangle here, MOC. If we find the other two angles, it will be very easy to find this. One angle is quite easy, right? If it is angle C is 108 degrees and P divides it into half, so this is 54 and this is 54. So we know what this angle is. All we have to find is this angle, M. So that again is easy, right? Consider the quadrilateral ABCM. It is a quadrilateral. So that means the sum of all the four angles is 360. But what are the angles? The first angle is MAB, which is 54 degrees. What is the second angle? Angle B, which is 108 degrees. And what is the third angle? Angle C, which is again 108 degrees. And what is the third angle? Third angle is what we want now. It is M. So angle CMO or CMA, whatever. That is what we need. All of that added is 360 degrees. This is similar to what we did the last time. So all of this added gives 270 degrees. So that means angle CMA is equal to 90 degrees. So this angle here is 90 degrees, and this we already said CP, the whole angle C is 108 and P divides it into half, so each one is 54. So now consider triangle, the small triangle COM. So the sum of the angles of the triangle should be 180 degrees. But then what all are the angles? First is angle O, right? COM. I will write COM to avoid confusion. Angle COM. And what is the second angle? OCM. And what is the third angle? CMO. And all of that added should give you 180 degrees. So angle COM is what we want. Angle OCM is 54 degrees because it is a bisector. The whole angle is 108, it divides it into half. And this angle is 90 degrees. We just found out. So angle COM is equal to with this we come to the end of this lesson. Till we meet again, take care. Assalamu alaikum.